Hey, welcome to Chapter 12, Examining the Calculations and the Validations. And the first thing we're going to look at are going to be calculations. They're found over in your Explorer panel. I've got it opened up right now. I'll scroll up a little bit so you can take a look at them. Here's the calculations. You'll notice that they're organized by table. And in some instances, they're organized by the method in which they should be run, 1, 2, 3, 4, and 5. So you can see which one should be run first and second and third. That's there to be able to keep you in sync with the way things are used in the database. The other thing that you need to be aware of is that we have we used to have a column in the old NASIS, and when we moved to NASIS 6, we created a superimposed source field. And that superimposed source field are these colored letters that you see in each one of theirs. And sometimes they get in your way, I realize that. But they're there for metadata to be able to provide you some information on it. And what does it tell me as a user of NASIS? The first thing is you see that P where my cursor is right now. And that P means that this was a prior converted data. So that 50% of number 2 passing a number 2 on the low, that means that that was populated prior to NASIS 4.0. That's easy enough for me to be able to figure out because that basically tells me some of this stuff is old 3SD data that's been converted over. Alright, next thing is, if it's not prior, then it could have been manually entered. And that's what the M stands for, meaning you've manually entered that particular field. And then the last one, the C that you are so frequently in this data set right here, that C means it's been a calculated field. So by looking at this, I can tell which one of these fields have been prior converted, which one of these are calculated, and which ones are manually calculated manual. Gives me some information about how this data has been populated. Now, why do we use a calculation? Well, there's a couple of things that you need to be aware of. Number one is the fact that it really serves a purpose if you're working on a lot of data and you want to just run the calculation and populate it. Horizon designation is a good example. You populate the master, you populate the sequence, and then the subscripts, and then you can populate the horizon designations based on what you populated in the field already. However, some of the things that you need to be aware of is that you may run this calculation and you may not like the results. Well, that's the best thing about a calculation. A good one to use as an example is the Conservation Tree and Shrub Group, CTSG. You can run that and run that particular calculation, and the reason why they're created as calculations is so that you can have a model to look at all this data and then present what that model's result would be and populate that particular field. So for Conservation Tree and Shrub Group, let's say that you run this on a suite of components. Now let's just see if we can find it real quick. We'll come over here and see if it's been populated. I doubt it. Oh, it has been populated. It's been manually entered. Okay, perfect scenario is that say some of these came out as a 10. In other words, we can't find a grouping for them, so we're going to stick them as a 10. And you say, no, this has always been a 3, and we're very comfortable with this soil being a 3. It has these same set of properties that we feel a 3 is in there, and I don't want to really go in there and investigate right now why that property is failing and it's coming up as a 10. You need to understand, we create calculations so that you can manually override, and this is a perfect example. You can go in here, run the calculation, look at the analysis. It says it's a 10. I know it should be a 3. I can go in here and populate it as a 3. Calculations were never meant as a defining interpretation. They were meant to assist you in the population of your data. If you want a defined interpretation, that is what the interpretations are for. You cannot change an interpretation. A calculation was developed to populate a field, and if the results were not what was expected, then you have the ability to override that, manually populate the field. So keep that in mind as you're using calculations. Okay, to continue on this idea, how do you run a calculation? Well, in order to run the calculation, the first thing you're going to have to do is you're going to have to highlight that particular field. I'm going to come down here because I think this is, yeah, it is. This is an STJR project, or an MLRA project. So I'm going to go over here and I'm going to check this data out. And, pardon me, it's like populating any other data set that you've got in here. It has to be checked out first before you can literally populate running calculation. So now I'm going to come back over here, and I'm in the component table now. I'm looking for what I've checked out. There they are. I'm going to try to bring them back up to the top of the field here. There they are. You'll notice what I was doing was clicking in the left-hand column. And that allows me to sort using this particular field right here. So I sorted, so I've got the three components that's in that data map unit checked out. And just for the heck of it, I'll come over here and I'll freeze this column so that I've always got these three identified. And now, pardon me, I can come over here and find any of these particular ones that I want. So if you'll notice that the slope length has not been populated in these, I can come over here and I can highlight all three of them. And then I can come over here to the slope length, USLE, and I can run this. And I want to replace the manual entries. There are no prior, but I'll go ahead and click it anyway. And it'll run through and it'll calculate. And now the slope lengths are all populated for that particular field. Now, what if I look at these and I think, you know, I've mapped this area long enough. I know that's not right. I can very easily come in here and I can change these so that they represent more of what I would have expected. And yes, I do know there's an error there. That's the reason why I want to come in here and change this one. And so now I've got that taken care of. So I hope that shows you that I'm looking. Let's put that back about 50 meters because I don't think it's 30 meters is enough. So we'll take it to 30 and we'll take it to 60. Okay, so that gives you a good idea of how you can literally come in here and overwrite a field. Now you'll notice that I just got done running that calculation, and that field, that slope length field, does not have the source that you see in the component. But you know, that's basically programming. We haven't caught up with all of our programming needs. It just hasn't been that big of an issue on some of these fields. So that gives you a handle on calculations and how they're actually used. And remember, you're responsible for any field that you put in there. Whether you calculate it or whether you then come in here and just manually enter the data, it's your data. Now, a couple other things. Let's go. Let's take a look at how are these created. I'm going to open up steel corrosion. And then if you'll notice in steel corrosion, this is nothing but SQL. And all the SQL does is go through there and grab the information necessary. And that's basically what you're seeing here. There's a series of SQLs extracting data from the database. And then we're doing a transformation of the data, no different than what we would do with a report. And then from here, it's still transformation of data all the way down to the end. And the difference between a calculation and a report is this last information right here, where it basically sets the steel corrosion from corrosion, and here is where it assigns what that corrosion is going to be. And that's the SQL necessary to do that. So I'm not going to go into details on how to write these because only Kathy Seibold is the major writer for these. But it just gives you an idea that these are all SQL. So it's not that difficult. Many of these calculations have been improved over the years, and one of the ones that's probably been improved the most by Kathy is the particle size estimator. And she's gone through and she's done quite a significant improvement on this. But you always review the data after you've populated using this particular calculation. Be very careful of anything within your three corners of your triangle, be it a silt loam, sands, or even the clays. And make sure that the sand separates are all populated appropriately based off of those textures. And that's the thing you have to remember the most on those. Now, I'm not going to go through all these because the intent behind this is just to show you that that's how a calculation runs. Let's close up the calculations and let's take a quick look at the validations. What a validation does, instead of populating a field, all a validation does is make sure that it runs a script through that data to verify. I know some of you run these reports, and you run reports and reports and reports. Here's an example of the one for the SDJR required component data. And you can run this for all rows in the selected set, or you can just run it for those that are highlighted. And I've highlighted those three. And basically what this allows you to do is take a look at all of those issues. For example, erosion class is missing for one of the components. And you can hit a print preview, and I'm going to expand this so that we can see it. And then here is that same set of information if you wanted to print it out or if you wanted to grab it for some reason. Okay, so that's basically what a validation does. It runs through and says, okay, is all of your geomorphology populated? Sure enough, there's no errors in my geomorphology. How about my parent material? Is it done? Here's my Russell 2. Have I got everything done for it? You can see how quickly these run. It doesn't take that long. Early on, I used to have the mother of all validations, and was asked shortly after I created it to break it down into individuals, and that's basically what we've done because of that. That's the reason why you don't see a lot of these grouped up. The SDJR is an example of one that runs many different calculations. And then here's the sand fractionation for I got to go over to here to horizon. I can highlight these. I can highlight just about any of them. I'll just run it on the whole thing. And you'll notice that we've got everything populated. We don't have any issues that that particular validation runs. Here's the Super 7 validation. I can run that on everything. And for those of you who are not familiar with what the 7 are, these are the 7 physical properties that are used in almost every single model that is using soils data. And what those 7 are sand and its fractions. You'll notice we've got coarse, medium, and fine sands listed here. It's the silts, it's the clays, it's your organic matter, your coarse fragments, along with your bulk densities, and then your water states, anything dealing with water. So those are your 7, sand, silt, clay, coarse fragments, organic matter, bulk density, and then water states, KSAT, water content. And so we've got a system set up that can very easily identify any of these fields that you need to go back and revisit, or you need to go back and populate. So we've got both calculations and we've got validations. They're not difficult to use, but remember, a calculation is designed so that if you don't have the proper data to be able to support calculating that field, you can always go back and overwrite it and put a manual entry in here just like that did. Once again, if there's any questions, comments, feel free to contact me. This is chapter 12 of the user guide. Just go through and run that or calculation or validation. If you have any issues, read the book, and if it doesn't have the answer, send me an IM or an email. I'll be talking with you later.